everybody to maths. And now yesterday you were practicing your division work using the inverse of your times tables. Well, today we're going to take that knowledge and we're going to do a little bit of a dropout lesson involving 3 sections. It's kind of like an amalgamation, love that word, of level up and drop out. So we're all going to stay together for the first section. Then we're going to level up, but year 3 and 4 you're going to level up to one area, and year 5 and 6 you're going to level up to another area, because it's kind of like you've dropped out. It doesn't make any sense, but we'll tell you what to do when we get there. Now, we're going to start nice and simple. We're going to start with something called arrays. Hip hip!
Arrays!
Not those ones. We're going to start with arrays that look like this. Now, you might have seen these before in maths, but what these can demonstrate, these dots on a page, is they can demonstrate multiplication and division problems. Now, if we counted all the dots, how many do we have, Mr. S?
12.
12. Now, how many columns do I have, though?
Columns is the one that goes down.
Vertical, like columns in a temple or in a museum.
There's 4 columns.
4 columns. How many rows, like rows of seats?
So we've got row, row, row. You boat gently down the stream. If you see a crocodile, don't forget to scream. Ah! We've got 3.
We've got 3 rows. So we've got the number 12, but it's split into 4 columns, 3 rows. So what this can demonstrate, watch, is we could say if we took each column, we've got 4 lots, 1, 2, 3, 4, 4 lots of 3.
Very good.
And that makes 12. Or if we took the rows, well, we've got 1 row, 2 rows, 3 rows, 3 lots of, and what's in each row? Oh, there's 4 in each row, so that's 4 lots. 3 lots of 4.
And that proves, what do we call this? Can you remember? That they are commutative. Very good.
Switch these 2 numbers around. Now, it also helps us with our division. Because you could say, well, we've got 12 there. And if I was to divide, split, share, group 12 into groups of 3, so I can say, well, I've got 1 3 there, another 3 there, another 3 there, another 3 there. Well, we'd have 1 group, 2 group, 3 group, 4 groups of 3. Or we could go the other way and say 12 split into groups of 4. Well, that would give us 3 groups of 4. So these arrays help us with division and multiplication problems. Yes, Mr. S.
Now, I get confused by this, and I know there's some children in my class who got confused by this too. Does this mean they're commutative as well? Because look, we've swapped those numbers around.
No, these are not commutative. Commutative are when we're swapping the numbers in the calculation around, but not the actual answer. These ones are what we call the inverse of our multiplication problems.
So multiplication is commutative.
Yes, like addition is commutative.
But division is not commutative.
No, division and subtraction are non-commutative.
Got
So
you.
that's your first level. We've given you a selection of arrays and some problems. And I want you to have a look at the arrays and figure out what multiplication and what division problems you can work out from those arrays. Now, you might say these are too easy, but it's just a warm-up. Just getting that concept of sharing and grouping larger numbers using these dots. So that is the first stage. Level up. Now, year 3 4s and maybe 5 6s, this one's for you. We're going to use a skill now called partitioning. Let's have a look at the number 63.
Good number.
And I'm going to divide that, I'm going to share that, I'm going to group that into 3.
Okay.
Now, I know my 3 times tables,
Me too.
but I don't know 3 times something equals 63. That's a very large number.
My 3 times table stops at 36.
Yeah.
As far as I can go.
That's not going to work. I could try now using an array, but I'm going to have to draw out 63 dots.
You get so hand after that.
Yeah, it's a bit ridiculous, isn't it?
So what else can we do?
So I'm going to have to use another skill. I'm going to use a skill that we've used before called partitioning. Can you remember what that means?
Partitioning is a good idea. So we split up the 63.
We split up the 63 into its 2 parts. What are the 2 parts of 63, Mr. S?
Well, I'm going to go into 10s and 1s, nice and simple. So there are 6 10s, which would make 60.
So 60.
And there are 3 1s, which is 3.
3. So we've partitioned the 63. Now, we're going to divide these separate parts by the number 3. So we're taking it a bit at a time, a chunk at a time. Now, let's start with the 60. Now here we can use an if I know, because I still don't know my 3 times tables to 60. But if I pretended for a moment that was just 6 instead of 6 lots of 10, can I think how many 3s go into 6? Or if I was to split 6 into groups of 3, how many would I get?
2.
2, because 6 divided by 3 is 2. Or 2 lots of 3 go into 6. But that wasn't 6, it was 6 lots of 10. So this number's 10 times greater. So what's going to happen to our answer?
It's going to be 10 times greater as well.
So 60 divided by 3 equals 20. Now we've done the 10s, let's do the 1s. 3, we're still dividing by 3. How many lots of 3 go into 3? Or how many groups of 3 can you get from 3?
This again sometimes confuses people, and I don't really know why, because it's really, really simple. Whenever you divide a number by itself, it's one lot of that number, so the answer must be 1. I've asked some children, and they panic and they go, is it 3, is it 0?
It's 9. 3 times 3 is 9, it's not times.
Whenever you divide a number by itself, the answer is always 1. So 3 divided by 3 is 1. 6 divided, sorry.
So there's 3. I want to put it into a group of 3. There's my group of 3. How many groups have I got? 1.
Group.
There's 3. I want to share it between 3 people. You have 1, you have 1, and you have 1. How many have we each got? 1. The answer is always 1.
Yeah. 3 divided by 3 is 1. 6 divided by 6 is 1. 178 divided by 178 is
1.
Always 1 when you divide the number by itself.
So we've divided the 10s by 3, the 1s by 3, and we've got these 2 parts, 20 and 1. Well, let's add them together. I don't think I even need to use column addition, but 20 add 1 is 21. So 63 divided by 3 is 21. We partition the number to break it down. Now 3s and 4s, that's only got 10s and 1s in it, but you're going to have a challenge where you've got all the way up to 3-digit numbers divided by 1-digit numbers. So just break them apart bit by bit. Use your if I know. Even if when you're in the hundreds, what's 200 divided by 2? Well, I know 2 divided by 2, so I know 200 divided by 2. Okay? Break it down. Now this is a dropout lesson, so here we're going to ask year 3, 4, 2... drop out, and we're going to head over to year 5, 6. Now 5, 6, thank you for bearing with us. They were very patient, weren't they? Now, what mode of transport we're going to need the 5, 6s to go and get on?
I'm sure what's available. We can't get on planes. The train service is quite reduced. Some taxi firms aren't operated as often.
Not really, no.
I mean, automobile transport's actually gone up, hasn't it?
Yeah.
Maybe the bus.
Let's go catch the bus. Where are they going to have to wait?
Well, you can... I mean, there's one on the top of Whitehead where you get the 82 if you're going towards Speak.
Yeah.
Oh, at the bus stop.
Hey! Took our time. The bus stop. That's where we were trying to get to. Because 5s and 6s and maybe 4s you've tagged along. Or 3s if you've tagged along because you like that. We're going to challenge you to divide using the bus stop method. Now, you need to have in your mind already when you come to the bus stop method that what you are doing is you're using your skills of arrays. You know how to break apart numbers. That's what's happening when we divide. You know how to use your skill of partitioning, that you're simply dividing each section as we go. Now, the bus stop method is just a written method that helps you do all those skills in a nice, neat, controlled way. But it does not work if you don't understand the concept of division. So if you're still struggling with what is happening when I divide, go back to the arrays and practice them a bit more. There's no shame in getting that skill sorted and understood in your mind before you come onto the written method. So let's try a bus stop method. Let's try the calculation. 488 divided by 4. Now we could break this apart into its different sections of its place value, but we're going to draw it out in what we call a bus stop. Now a bus stop looks like this in maths. Simple like that. That's the bit that goes into the ground, and there's the area that protects you from the rain. Now we always put our large number, our number that is being divided, inside the bus stop. And we put our smaller number, the number that we are dividing it into, outside the bus stop, sort of behind it, like this. Now I know that looks very confusing because it's the wrong way round, but you've just got to remember division kind of has its own little rules. So here we go, we've got 488 divided by 4. Now there's one other special rule when we come to division, because it's just a strange one, and it's this. With addition, multiplication and subtraction, we always start with
The ones.
But division is kind of like its own little law unto
He's the
himself.
odd one out, isn't
He doesn't do a
to be
column
honest.
method.
None of the others talk to division as well because he thinks he's great, and apparently the others just like, I haven't got time for you, mate.
He doesn't do a column method. He doesn't even put the numbers in the same order. He doesn't have his symbol in his written method like all the other ones do. And he doesn't start with the ones. He's a proper little rogue. But he works, so we just got to let him do what he does.
Yeah, I mean, he's not everyone's cup of tea, is he?
If he's not broken, why fix it?
Precisely.
So, we don't start with our ones. We start with our hundreds. Now, you know this is 4 lots of 100. But if we picture it as a digit on its own, we can imagine it just as 4. And as long as we're strict with where we write our answers and keep our place value columns exact, it will work. Now, you know this is 400, but let's treat it as 4. How many 4s go into 4?
1.
1. You should define itself by itself. So 4 divided by 4 gives me 1. Now above that hundreds place value number, I'm going to write that 1. And it's in the hundreds column. I know we don't have any other digits yet or any placeholders shown as 100, but we will get there. Now we've divided 400 by 4. Let's cross it out to know that we've used it. Let's go on to our tens now. We know this is 8 lots of tens, but let's pretend it's 8. 8 divided by 4. How many 4s go into 8?
2.
2. And that goes into our tens column because we've been working with the tens. Off it goes. Let's try the last one then. Now we're in our ones. How many 4s go into 8? Well, we've done this before with the tens. 2 again. And it goes into the ones place value. And you can see now that our hundreds are in the hundreds column, our tens are in our tens, and our ones have stayed in our ones. How many times does 4 go into 488? Or, what is 488 divided by 4?
122.
Nice and easy. That was your first level year 5 and 6. Go and have a go at those questions and come back to level up one more time. It's time to level up. Right, I'm going to give you a tricky one, Mr. S.
Okay.
Really tricky one. Let's set out in the bus stop. Draw our bus stop. Our larger number goes inside. And our smaller number on the outside. So remember, it's written backwards. We don't have to use the division sign. And we don't start with our ones because it's division, he's rogue. We start with our hundreds.
Yep.
Let's see why this is a level up.
So
3 into 3.
1.
3 into 8, or 8 divided by 3. Now this is where it gets tricky.
You can't really do 8 divided by 3, can you?
Should we,
Goes into 9, goes into 6.
should we get an array out to help us again then?
Yeah.
So here are 8 little dots. Now I haven't set them out like an array, but we are going to group these into groups of 3, or divide it into 3. So,
Group of 3 there.
there's a group of 3 there. That's 1.
And there's a group of 3 next to it there.
There's another group of 3 there.
And then we... well, can I just do one anyway there and just say it's close to a group of 3?
We can't because it's not a group of 3. We can't say, oh, it's close. So how many groups of 3 have we got there, Mr. S?
We've got 2 groups of 3.
We've got 2. Now, they are the whole groups of 3. I cannot get any more. I'll double check just to see. No, there's no other way of getting another group of 3. I can only get 2 whole groups of 3 out of 8, or 8 lots of 10. So I'm going to place that 2 above the 8. Oh, I forgot to cross out my hundreds. But I haven't used all of the 8. And I can't just forget about it and say, that's all I can get and move on. Because otherwise I won't have used the whole of my number. And remember, I need to use all of it. So what do we do with this? 2. Well, we say it's 2 remaining because we've divided it into groups of 3, but there's 2 remaining at the end. So what we do is we regroup them into the ones. So we kind of go the opposite direction to what we're doing when we're timesing, adding and all that. We regroup it into the ones. So we've said we've divided 8 by 3 and we got 2. But there was 2 remaining, so we move that over into our ones. Now it's hard to picture there, but that now becomes the number 24, because remember they were 2 lots of 10 that were remaining. So 24 now divided by 3. This is where you need your times tables.
8.
Is 8. Just like that. 128. Now let's try one more for this level.
Right, let's dive into this one. 722 divided by 7. Let's go. So, how many 7s are in 7? 1.
And it goes in the hundreds column.
7 to 2. Oh, we can't get any there, can
There's
we?
no groups of 7 and 2. Don't do the mistake that my class sometimes made where they go, how many 2s in 7? 3.
Yeah.
Not that way
It's
round.
not commutative. Remember, that's really important. You can't just swap things around, can you?
No. How many 7s go into 2? Mr. S is right, none. So we put the 0 above here. But wait there.
I always forget that bit.
Oh, I forgot to cross out the hundreds.
I always forget to put a 0. You can't just move on and think, oh, there's nothing there. Place value is all important, isn't it? That's a placeholder. So you've got to put something in. You can't leave the column blank.
Yeah, absolutely. But as well, don't forget, we were trying to get groups of 7, but there weren't any. There was no groups, but we still have those 2 10s. So we've got to regroup them into the 1s. So that comes 22. 7 into 22. How many 7s go into 22?
Well, 3 7s make 21.
That's very close. 3 7 makes 21. So we've used 21 of them to make 3 groups. There's only 1 left over. Can you get another group of 7 out of that one?
Definitely not.
So 7 into 22 goes 3 times. But we still have that 1 left over. But we can't just carry him anymore. I mean, we could. Some of you in year 6 maybe can carry him to the next decimal place, into the 10th. But we're not going to, because we've just got 1 remaining. So our answer here is 103, but we need to show we've still got that 1 remaining. So we draw a little r that stands for remainder. 1. So how many times does 7 go into 722? Well, it goes in 103 times, but you will have 1 remaining at the end. Maybe we'll come back to another division lesson tomorrow where we can go over this a bit more thoroughly. For now, just practice the levels we've given you, practice the ones you can do, and if you are struggling with anything, get in touch. We are your teachers during this time, so we want to help you. It's not just about us talking and leaving it, we'll give you feedback where we can, so please get in touch. Division is a tricky little mistress. Bye.